All right, suppose a ball is dropped from the upper observation deck of the CN Tower in Toronto. It is 450 meters above ground. Find the instantaneous velocity after 5 seconds. All right, so we are finding instantaneous velocity. So that means in 1 instant, okay? So that means if I only have 1 point, it is technically the slope of a tangent line, okay? Instantaneous velocity. So what we do in order to do that is we kind of make ourselves have 2 points, okay? So the first one is when t equals 5. The other point is when t equals 5 plus h. So our setup then is our limit as h approaches. Well, in theory, I really only want it at 5 seconds, so I need h to be 0. So as h approaches 0, okay? And then I'm going to label this function f of x. Usually they're labeled. I would find f of my first time, 5 plus h, minus f of 5 all over my 2 time values. 5 plus h minus 5. One thing you guys can maybe take note of the denominator, when I'm finding instantaneous velocity, every time those should cancel out. So you're just left with h in the denominator. So this part right here is really the difference quotient, which you've solved before. Okay, the new part is this limit as h approaches 0. So here's your setup. It is important that you guys write down the setup before you actually go ahead and calculate it. Okay, so I'm going to find f of 5 plus h. I'm just going to do that off to the side here. F of 5 plus h. So that equals 450 minus 4.9 times 5 plus h squared. Now, 5 plus h squared I got to write twice and FOIL it. So I got 450 minus 4.9. Now I'd have 25 plus, then I'd have 5 times h, so 5h, plus 5 times h, so plus 10h, and then plus h times h, so h squared. Okay, if you need to take the time and FOIL it and then combine like terms, you can. So then we'd have 450, and you distribute a negative 4.9. So when I distribute my negative 4.9, I would have negative 122.5 minus 49h minus 4.9 h squared. Then I would just combine my like terms, okay? And so I would have negative 4.9, I'm going to write in standard form, h squared minus 49h, and then 450 minus 122.5 would be plus 327.5. Okay, so here's my f of 5 plus h solved. So this is kind of like my side work. That's what I like to consider it. Okay. Oh, and I also need to include on my side work f of 5. So I'm going to find f of 5 as well. F of 5. So that would be 450 minus 4.9 times 5 squared. Okay. So if you go ahead and find f of 5, you should get, calculate that in your calculator, 327.5. There's my side note all the way finished. Okay. Now I'm going to go ahead and plug it in. I'm not plugging in h equals 0. I can't, okay, because I can't divide by 0. So in order to do this, I need to still write my limit. Okay, that's the technical way you'd show this. So it's our limit as h approaches 0. And then I'm going to write, well, what was f of 5 plus h? It's simplified to negative 4.9 h squared minus 49h plus 327.5 minus my f of 5 value, which is 327.5 all over h. Now you guys, this is very similar. They should cancel, okay? And I should be able to factor out an h. Still got my limit though, because I can't plug in 0 for h. I'd have an error in my denominator. Factoring out that h, the h's will then cancel. And now I should be able to plug in 0 for h. I will not have a domain error. So I will have negative 4.9 times 0. So notice you guys, I'm plugging in 0 for h, so I'm stopping to write my limit, minus 49. So that will give me negative 49. And now I just need to talk about, well, what is the label on this? So it is whatever the value of your y's over your x's. So x's are usually easier, seconds, right? So something per second. And then I just need to figure out the label for my y values, meters. Okay, so my instantaneous velocity 5 seconds after that ball is dropped out off the tower is negative 49 meters per second. Okay, a lot of you might be like, can it be negative? It can. The reason it can be negative is because it's going downward. Okay, it's going down, so it's showing the direction. Velocity shows speed and direction, and so there is my instantaneous velocity of that ball being dropped off.